Hello, and welcome to this eCampus News webcast. My name's Andrew Barber, and I'm a senior contributing editor here at eCampus News, and I'll be acting as the moderator for today's presentation, which is sponsored by Aruba. And over the next hour or so, we're going to do a dive into discussing what it takes to implement a mobile-first strategy on your campuses and how advances in switching technology now make it possible for even comparatively lean IT shops to provide consistently reliable network performance for their constituents. And before we get started and dive into that, I do want to take just a few moments to highlight a couple of items about the console that you're looking at today. First, we are recording the event, and in a couple of days, we'll send an email out to everyone who registered for the webinar that will contain a link to the recorded event. And you'll also be able to download a PDF of the presentation from that same email. And second, please do ask questions. Don't feel as if you have to wait until the end. If you have a question at any time during the presentation, just type it into the Q&A box and on your console and hit the submit button. And I think we'll have some time at the end of the presentation when our speakers can address your questions. We also have a chat function which you can launch if you look down at the bottom of the console at the blue group chat icon down at the bottom there. Please use chat to talk among yourselves or to contact me or the eCampus News team if you have technical issues or any other concerns. But please don't use the group chat to ask our panelists questions. They're simply not going to have time to monitor the chat. So if you have a question for them, please use the Q&A panel instead. And while we're talking about technical questions, you do need to have the Flash player enabled. And if you look at the media player panel on the console, there's a link there that allows you to do that. So with that out of the way, let me now introduce you to today's guest. Vince DiStasi serves as CIO and VP for IT at Grove City College in Pennsylvania. And it's a position he's occupied since 2002. And in addition to overseeing all aspects of IT on campus, he serves on the faculty as well, teaching business computer applications in the college's business program. And a little later in the hour, we'll also hear from Sue Gillespie, a senior product marketing manager at Aruba. And Sue has more than 20 years of product management and marketing experience in the networking industry and is responsible for guiding and developing GTM positioning, marketing launches, and communications for the Aruba Mobile First campus switch portfolios. And finally, we'll also hear from Alan Sardella, a senior product marketing manager in Aruba's campus switching and software division. And Alan has been in the networking industry for 15 years, working for a variety of vendors and open source providers with a focus on routing, switching, and security. And he has recently specialized in software-defined solutions such as telemetry and automation. But first, we're going to hear a bit about Vince's experience at Grove City. And just as some background for everyone, I interviewed Vince a few months ago for an eSchool News article about how he and his team essentially redid the campus's entire wireless network in the course of a summer. And I wanted to follow up with Vince today on some of the themes that emerged for that article and dive a little deeper into the thinking and technology behind what he and his team did. Welcome, Vince. It's great to talk to you again.
Thank you, Andrew. I'm happy to be here, and I want to thank Aruba for the opportunity to speak about our experiences with their solutions over the last few years.
All right. Well, great. Well, why don't we start, give the audience a little background about Grove City, and in particular, what led you to embark on a decision to completely redo the network. Can you start with that?
Sure, absolutely. So Grove City College is a comprehensive liberal arts institution that is located in northwestern Pennsylvania, about midway up the state and very close to the Ohio border. We have approximately 2,400 students, give or take, and we cover both science and STEM fields as well as traditional liberal arts and letters fields. And we've been doing a one-to-one program for, 25 years now. We started back in 1993, 94, where we started providing every one of our students with a laptop, and then that migrated to these convertible devices that are tablet PCs and laptops to maximize the use of student technology both in the classroom and outside of the classroom. So we kind of think of it like a mobile lab. So instead of having a lot of lab spaces located all over campus, we basically have very few labs except for some specialized ones for music and engineering and communication arts. But outside of that, by and large, we have no labs. And so it was important for us to make sure that the students, while we're providing this solution, are capable of using these devices both in the classroom as well as after class outside the classroom, and essentially 24/7, because that's typically how they work. And so as we were designing these networks, what we found was that as more and more of these consumer devices became available, students were coming back on campus with them. And we started noticing that we started to have some degradation of our wireless networks on campus. So when we planned for the wireless networks, we planned for specific scenarios. And that basically meant, we were looking at our own devices that we were providing the students, as well as just a little bit of overhead, because we have a mix of both wired and wireless networks on campus. Where we started to feel the pain a little bit was in our library, and that's kind of what led us to say we really need to reevaluate how we do this wireless network.
Okay, and I believe you did a sort of stealth approach on the library and did the upgrade and then sprung it on them. Is that how it worked? I seem to remember that you telling me that there was that suddenly performance in the library just took a leap year forward.
Yeah, that was correct. So what we had done is we looked at that library where students on a regular basis would tell the librarians that depending on where they were in their performance wasn't adequate or not working. So what we had done over an Easter break was we basically went into the library that weekend and replaced all the devices, all the APs in there with Aruba APs. We had done a site survey prior to this, and then we just went in there and just replaced them. And the only people that knew were the librarians. We had done that and said, let's see how this works. And then the students had come back that Monday, and we went from complaints daily to literally 0 for the rest of the semester. So not a single complaint.
Okay, great. Well, you talked just a little bit before about wired and wireless, and you have talked about pursuing this wireless first strategy, but you have also pointed out that wired is not going away. Can you discuss a little bit what that means exactly?
Sure. So the wireless first strategy really comes out of the fact that even the devices we're buying today for our students, and in this case, they're HP devices, but most of the X360s and the devices we're using don't even have network ports on them. So short of using a dongle, things are more and more designed for wireless. But there's also situations where, depending on performance and what you're trying to do, that a wired network is necessary. First off, you need the wired network to connect the access points and do the backhaul. So those wires are not going away. In engineering labs, for example, or highly visualization type labs, you're going to need, depending on what you're pulling across the wire on the size of the files and what you're trying to do in a timely manner, the wired networks still have a speed, performance, and an advantage to that. Or if you're in an environment where things are going to be highly secure, obviously a physical network connection is more secure, and it's not shared, because when you're going back to a network port, it's basically dedicated, where, wireless technology, we're using a shared resource. And then probably the big thing that we look at also is services that are providing edge-based computing. So if we look at graphics-based workstations that are now going to be located not necessarily in the classrooms themselves, but they're going to be located in a data center. Those are obviously going to be wired, because the performance of what they're sending back and forth has to be very, very high. Then we have some issues with IoT devices where there are some IoT devices that aren't going to be wireless. They basically have a RJ45 jack on them. You're going to plug them in, and that's the way they're going to work, and there's not going to be any wireless component to those IoT devices or meters or those types of things that would come on campus. So depending on what the user expects and what the user experience is and what device they're using, we think that there's a synergy to be had between wireless and wired networks. So we don't view one as much more important per se than the other. We think that wireless is being used more and more, and a lot of that are smaller type devices or quick access to stuff, but we also still think that wired networks are important, and they'll continue to be important as we move forward.
All right. And during our conversation before, you talked about the importance of the management of wired and wireless being a sort of unified, holistic approach, which is counter to how a lot of schools currently have those, can be slightly siloed, the management of those. Why is, maybe you could just expand a little bit further on what you said just now, the idea of a unified management, why is that important, and how do you actually do that?
So one of the challenges is it depends on which direction you're looking at it from. So if you're looking at it from an end user direction, we want the end users, for example, regardless if they're on a wireless network or a wired network, we want them to have the same resources that they're used to having, regardless of what device they're using. So having that unified management is really important to make sure that whatever rules you apply are going to be applied across the board, regardless of the type of device. So, you know, for a wireless user, you have to worry about the fact that space really, for some, isn't really an issue. So where they're located at doesn't dictate what services they're necessarily going to get, especially on a college campus. So if they're studying in their dorm rooms or studying in the library or studying in the engineering building or the arts and letters building, they get the services they get because of who they are, not because of necessarily where they're at. So that's really important to us. But also from a wired perspective, we'll take, for example, students' laptops, tablet PCs that we have. We give them docking stations as well. So when they go back to the room and they connect to the docking station to either charge up their batteries or do multiple displays or whatever, at that point, when they're on the dock, their dock is connected to a wired port that's in the room. So they're getting wired connectivity that way. So we want to make sure that regardless if they're wired or wireless, they're getting the exact same feature set that we're expecting them to have, and similar performance. I mean, some performance is just by necessity, depending on the medium, going to be a little bit different, but by and large, we want them to have the same performance or expectation of an application that it performs the same no matter where they're at. So trying to pinpoint problems becomes a little bit less difficult when we have a management situation where everything is integrated versus having to pull up two different panes of glass, trying to correlate, well, you know, what's going on here with this MAC address, which is the Ethernet MAC address, versus what's going over here with the wireless MAC address. And so having it unified just starts to make things a little bit more simple, and you start treating the individual or the end user as the start and trying to figure out what's going on.
Okay. And which tool are you using to give you that unified look at the networks?
So currently we're using two tools that provide both authentication and also the view. So we're using ClearPass. So students have to register their devices so we know who owns what. In the case of our own devices, we kind of already pre-populate that information. And then currently we're using Airwave, which is another Aruba product that helps us manage and look at those switches and also the access points and up to and including the end user device. So typically you'd think of a situation as an end user. End users don't really are concerned about what the infrastructure is, right? They're concerned about their experience. So if they can't get somewhere on a wireless network, they would automatically say the wireless network's down, which may or may not be true, or it may be that particular access point, or it may be their device. So what Airwave allows us to do is look at that access point, see what else is going on to it, actually go down to the device that was fingerprinted and try to figure out what's going on. So we're relying on the end user to tell us they're experiencing a problem, but they typically try to diagnose that the problem is the wireless network's down, which is not necessarily the case. So those are the two tools that we are currently using. Now, we are investigating some other tools that Aruba makes as well to provide a consistent interface. And one of those is NetInsight. And that's a cloud-based service that collects information through collectors, and it collects information on how long does it take somebody to authenticate, what the network traffic should be looking like. It gives us insight into what's coming up versus being highly reactive at the end when we notice there's a big problem where we could have circumvented it and seeing it build up. And then there's also sensors like Cape Networks. So a Cape Network sensor, for example, simulates an end user. It's just a device that basically you program. It's also cloud-based. You program it to connect to your cloud-based services, and it continually monitors what kind of performance you're getting there. So instead of relying on a bunch of users at the end to say, hey, this is really slow, we do that. We simulate users. That's the hope, to simulate users and get that information up front so we know ahead of time that something's going on.
Okay. All right. Well, I want to move on to some discussion of security and performance. You've talked a lot about how students are, there's just this flood of student devices coming onto the campus and faculty as well. And you touched a little bit on how much, IoT is coming into play. Maybe you could talk a little bit about what you see coming down the road in terms of IoT and the next wave of devices, and how what you anticipate happening. And then I want to sort of start talking about how that impacts your security plans and how you're going to actually put all of this onto the network and maintain security. Can you talk a little bit about IoT and what you see happening down the road?
Sure, absolutely. So we kind of group IoT in a few different buckets. So if we look at the student side, for example, and even some of the faculty, we're talking about some IoT devices that are more consumer-based IoT devices. So things like Alexa or HomePods or whatever that are connecting to provide a personalized service to an end user. So it's more of a consumer type device. So we even have students, for example, bringing Google Home products into the campus to control the lighting in their dorm rooms, up to that type of service, right? And then we have IoT devices that we consider as an institutional asset. So IoT devices that might monitor energy consumption or might monitor traffic, through a building, lighting automation systems, sensors that are continually working on room occupancy, for example. So we have conference rooms, for example. How do you know if they're being utilized? So are people booking them and using them and staying there, or are they just being booked and not being used? So all these IoT sensors that we're talking about, we look at it and we kind of figure that there's different types of security that we're going to have to employ. So like for security on our IoT devices that to run the institution or to collect information on the institution, we certainly don't want students that are on the network 24/7, being able to see into those IoT devices or do anything with those IoT devices. So, we need to segment them. We have to use certain firewall rules to make sure that only certain things can communicate to them. So we do that type of stuff. In the dorm rooms where students might bring these other home devices, we just want to know what they are, because at some point, if they misbehave, we need to know where to find them. We can't try to find them like a needle in a haystack on campus somewhere. So using the ability to use those and get those profiled and registered are of the utmost importance to us when the students bring those devices. The other thing about IoT devices, too, is if we're relying on IoT devices to provide information to us, we want to make sure that that information that they provide to us is done in a timely fashion. So making sure that they have adequate communication pathways, making sure they have enough bandwidth. So it's more than just, security. We also want to make sure that they're working in the real-time fashion they're supposed to work in. So it's kind of two different buckets. And then you also think about business automation. So sensors might be like Aruba beacons, for example, where students want to sign up for a conference room that isn't being used and they want to use their mobile device to do that, or wayfinding, that type of stuff, to do that type of stuff. So there's a whole host of different scenarios where we would consider IoT, but we realize that that's not going to decrease. That's going to just continually increase as we're looking for business modifications to make things more efficient from a student self-service perspective or a faculty self-service perspective, or IoT devices to do data gathering so we can make more informed decisions on what we're looking at and pinpoint trends and look at analytics.
Okay. All right. Well, you're talking about IoT and some of these student devices. I mean, the load on IT seems to be getting larger and larger. And I don't know how Grove City is, but many schools are not seeing a commensurate sort of increase in the size of their IT department or staffing. So there is this drive towards having the networks be as automated as possible, and you talked about NetInsight earlier about actually starting to create autonomous networks. And I do want to talk a little bit about how important automation is to you in IT, and how important it is to have visibility into your network and what that means from a performance standpoint. Can you talk a little bit about what is automated now and how that's impacting how your IT staff reacts to everything?
Sure. So most of the automation occurs at the level of students providing some self-service. So, as far as like segmenting our network and that type of things, we have two networks on campus that are wireless. One is just called GCC and the other one is GCC Guest. So the expectation is that if you have a Grove City College Active Directory account, you're going to be at GCC, and then all the parents or visitors, visiting lecturers that may not have that are going to be on GCC Guest. So part of the automation is that we don't onboard them in the sense that you're going to give us the information, we're going to onboard you. We actually have the end users onboard themselves and categorize that information, and then we look at it after the fact and see if there's any way we can make these a little bit more automated. In the case of some end user, like some institutional labs where the product doesn't necessarily belong to an individual. It belongs to the institution that may be communicating via wirelessly. And so it might be like Android tablets, for example, or iPads that students may be using for a course. We preload those up front, so there is no registration for the student. So that's automated in the sense that we do it like at one point, but they don't have to do anything. It just kind of works the way it's supposed to work. Where we want to go over the long term with the NetInsight is not having to continually look at it and be reactive to it. So if there's certain things that are occurring, we want if an end user, for example, if there's a pattern, so this would be more of the introspect product, right, where it's a cloud-based solution. It understands patterns. So if we have a guest, for example, that's on campus who's registered for the guest network and something just doesn't look right, we want that system, in this case with introspect, to basically be able to quarantine it with no intervention from us. Now, the intervention would be, hey, this end user is no longer being able to do this. Can you help? And then we can figure out what the problem is. But that type of stuff. And you're right, our staff is also stretched. I have one network engineer that manages the entire fleet, the entire network. He has a backup. In me, I'm kind of his backup, but my focus is more on storage and server type administration, so
Yep.
I'm not a network engineer. So having some of that automation in place also helps in that scenario. So if we're using things like scripts that automate how to do something, instead of me having to be an expert in the script is already written, he and I would use the same script, so we should expect the same outcome versus his skill set versus my skill set.
All right. Now, when we talked a few months ago, you had you talked about how important it was that when you were buying these Aruba switches, including I think the 8400, that they have open APIs on these switches. Can you talk about what that means to you and why that was so important?
Sure. So in the case of like the 8400 core switches, which we replaced this last summer, the ability to use these open APIs to get automation into them or integration into other products is really important to us if you want a holistic look of everything. So what we're trying to do is we realize that we have just so many panes of glass that we're looking at, and trying to correlate all of that and getting things to talk to each other is a little bit challenging, especially if you have a staff that is lean. And then also what our staff is used to, right? So if we're more CLI-based or if we're more GUI-based. So what the open APIs allows us to do is integrate not only the 8400 series or the access points, but to get them all to communicate together so we have a consistent data gathering and data flow from point to point, and we don't have to artificially try to join the information together because it's going to be there for us. So it doesn't matter if we're talking about security like ClearPass or security like Palo Alto Networks or whatever we're talking about, those APIs to be able to go in there and program them and pull information out of them, regardless if we're using Python scripts or whatever, is really a great way to standardize and say, we are looking for this type of information, we're going to run these all the time, and we're going to continue to gather information and see if there's any anomalies. That's a big time saver for us, and also for if we want to automate a lot of different configurations, for example. We just do one configuration, automate it, push it out, it's done.
Okay. All right. Well, we are. I'm going to probably have only a couple minutes more with you before I hand things over to Sue. So, just what you did at Grove City over the last couple of years was a pretty major redo of the network, and I understand also that you have been replacing the switches in buildings every year. You replace the switches. Based on all that experience that you've garnered over the last couple of years. What are some of the lessons learned that you would share with colleagues in this audience, for instance? What are some of the big lessons you learned, things you would have done differently if you could do it all again? What are some of those lessons?
So I would say probably the first lesson learned is to make sure you understand what the end game is from the perspective of the end user. So, when we first started down this journey, when we got the complaints, for example, from the library, we had done site surveys prior to that, and it wasn't that our libraries, the APs that we had in the library were in the wrong place or they were the wrong type. They worked for a while. The problem is that they just got completely overwhelmed with density. So understanding that concept of, okay, things are now moving, where we used to think of wireless as just like an augmentation of wired, and now we started to realize this just is not the case. This is not the way things are going, and so understanding that you rely on companies that are heavily invested in this type of technology to help you through. There's a lot of similarities regardless of industry. So even though we're in education, for example, in education we're on 24/7. We have a lot of density, a lot of students, and to some respects they almost simulate like going to a sporting event, right? So, but that's like all the time, depending on where they're at. Yeah. So just understanding that there's similarities in these networks, that education isn't like unique to itself. We grapple with a lot of the same problems a lot of the other industries grapple with, but we also know that we have students on our side of the network here all the time. So understanding user expectations and what they plan on using. Sometimes you just have to say, well, we're just going to need to provide more density, or the other lesson learned is you try to explain to students that this is a community, and there's only so much that we can do, and to tailor their expectations that way. So I think it's like a two-way conversations with them as well, because, I mean, students typically, if you look at a life of a student throughout the day, it's very, very different. There's work, there's watching Netflix, there's some downtime playing games or whatever. So these network patterns are a little bit very different. We can't just say, well, they're only used for academics, because there's a lot more to it. So I would say just understanding what your end users are expecting, and understand what the faculty are expecting in their classrooms or in their labs, what type of performance they're expecting, and just being open about what you can and can't do. And, you know, us replacing network switches, obviously, we have to do that, but we also have to do that because as newer technologies come out and these things all communicate with each other, we want to make sure they can interoperate fine as well. We don't want to just start artificially building islands of networking in certain locations. So.
Okay. All right. Terrific. Well, thank you so much, Vincent. I'm sure the audience, if you have questions for Vince, please put them into the Q&A panel, and we'll try and get to them at the end of it. So thank you so much, Vince, but I hope to come back to you in a bit, and I want to change gears at this point and bring in Sue Gillespie to talk about campus switching and some of those innovative technologies that Vince was talking about. So I'm going to hand it over to you now, Sue. Welcome.
Thanks, Andrew, and thank you, Vince, for sharing your experience and lessons learned, and also really for putting your trust in the networking solution and team here at Aruba. Grove City College, your story really does exemplify how IT's delivery of a network that's high performing and secure can also really deliver that best experience to students and professors, you know, no matter where they're connecting, whether it's in a dorm room or, you know, on the quad or in a classroom. It helps us substantiate, you know, that IT is really key to the teaching and learning experience, you know, and that's all part of the user experience. But, you know, as you kind of dove in, building a campus network that's really ready for whatever the future brings is a challenge. You know, we understand that it requires, you know, a lot of technical planning and that it's complex. And so it really requires building a network that's ready for all those new mobile devices, new IoT devices, that supports new use cases, all the while all those students and other users enjoy that great Wi-Fi experience, no matter what type of device, what type of application or location. And that this network needs to be available 24/7 because we all know that the campus never sleeps. So helping build networks like Grove City College campuses, ones that are smarter, even more secure and simpler with no compromises for performance is our Aruba priority. And our switches help provide the wired foundation for this. And today, Al and I are going to highlight two innovations that will help you ensure that not only, you know, students, professors, all users have that best connectivity experience, but these are new innovations of technologies that are going to help provide new unified ways to handle and secure that access layer. And that's with dynamic segmentation or dynamic micropolicy. And that's what I'm going to cover first. And then Alan's going to cover how we've created really a new modern approach with intelligent visibility that's automated and very programmable at the core, the heart of our network with the Aruba Networks Analytics Engine. So let's start with securing the access layer and how that's become more complicated and troublesome. So Vince talked about the rise of IoT on the campus and the need to be able to locate, identify, and bring those devices safely on the network. And we really hear about this challenge across the board from higher ed, really all of our enterprise customers. Many of these new wired IoT devices, you know, security cameras, HVAC, door sensors, other types of meters, they're not able to authenticate. So having secure access and onboarding is top of mind for IT teams, across the board. Today, the way it's done, to provide that network access to users and devices, we usually separate traffic. We generally separate the traffic to give the users and devices access to specific data and systems. So an engineering student can access that research network. Faculty maybe needs access to a student records SharePoint. And we also separate for reasons like quality of service. So those dorm students' YouTube viewings of the latest Kanye video clip doesn't blow out performance for those who are submitting maybe online tests or homework. So you're able to separate and segment that out. And this determination of users and roles and policies has worked really well in the wireless world, but with wired, it's been handled very separately by port, very static manual configurations with a heavy reliance on VLANs. And that becomes much more difficult to manage as larger number of devices and different types of devices come on the network. Or as Vince mentioned, they come on in different ways where you have a student that's coming in via a wireless, but then when they get to their dorm room, they put it in a docking station. Now they're connected via wired port. So what we've done is we've had a goal of to advance to a more secure, simpler network access. And what we've done is innovated around three key areas. The first is to take and have an approach of having a unified role-based access that provides that consistent user experience no matter how the user connects, via wired or wireless, so that it can also identify the IoT device, say a camera, and then it can provision accordingly. And the other goal, the second goal is to simplify configurations so it's not so time-consuming on IT's part. And the third is to help improve that segmentation so that the traffic and data is secure and only those who need access get access. So alongside that, we really believe that the wired networks needs to be smart, and so we have this new innovation called dynamic segmentation as part of our secret sauce, and it plays a solid role in securing wired users and IoT devices. And this hits on that goal of being secure and simple. And what we've done is we've created a solution that treats wired traffic similar to the way wireless traffic is treated, in that the traffic between, for wireless, the traffic between access points and controllers uses tunnels. So we've taken this and applied this to switches. So a separate tunnel is used to transport network traffic on a per user or per port basis from a switch back to an Aruba controller. And so here's a graphic that shows the wired traffic from users or IoT devices going through the switch, and then back for authentication and provisioning by the Aruba controller. So what you have is you have authentication and policies applied and enforced at the controller just as they are for APs. So that means that you've simplified your policy management down to a single location that's at that controller. And then it also allows users, because it cares who I am, not how I'm connecting, it allows users consistent access as well as permissions. This approach also means that the Aruba controller's firewall and other security features are available so that as new devices come on the network, say all these new IoT devices that cannot self-authenticate, they can be identified and only allowed the access that's defined for them. And so how this plays out is when an Aruba switch sees a new device, if it doesn't recognize it, it'll send it to the Aruba controller, and then together with Aruba ClearPass, set a policy trigger to start tunneling the traffic to the controller and do some deep packet inspection. So this gets really relevant and fun if you're a bit of a nerd when you think about the possibilities with IoT, because whether that wired IoT device is a thermostat, any of the sensors that Vince mentioned, HVAC, lighting, Its role can be defined that no other malicious or rogue devices or people can plug in, breach the network, and have access to areas of the network they shouldn't, say finance records. So you can dynamically segment that IoT traffic into secure tunnels to protect both that traffic and then protect other critical clients' traffic. This delivers a better, consistent user experience because that same policy is applied wherever that wired or user IoT device is. And as I mentioned, it simplifies that wired port policy operations because that policy follows the user or follows the device. And it can really help reduce IT workload when you're rolling out, hundreds of devices at a time or trying to do those configurations. This kind of segmentation can also help possibly, say, for your campus retail store because it helps with PCI compliance in that it can separate the traffic out that way. And then being able to utilize those built-in controller security services is a big advantage, the firewall, packet inspection, and fingerprinting. And finally, and quite importantly, this is a solution that doesn't require you to completely revamp your entire network. So you can take select network areas, deploy an Aruba controller and an Aruba switch, and have this dynamic segmentation, and then you can continue on with your VLANs, say, in other areas. So, we're trying to keep it simple for you. And next, I'm going to hand it off to Alan.
Right, thanks, Sue. And so the next major innovation in how the switching infrastructure supports the capabilities of wireless access and roaming, and of course also IoT, is in the analytics and the visibility and the automation that we actually and quite uniquely have built into the core of our networks. So the visibility itself comes from the fact that we continually record events, counters, networking states, for all kinds of things, links and protocols, and we store everything in what we call a time series database. So this gives our IT departments, or rather our customers' IT departments, which are always budget constrained, and which of course can be even more so within schools, access to the necessary insights they need to quickly investigate problems. Beyond that, we have ways to perform many of the initial tasks that you would typically need to have performed by skilled IT staff to diagnose exactly what's going on. So for instance, even before an IT person gets involved, our core network can already have taken the steps needed to remediate or at least get to the bottom, get much closer to the bottom of any problem. And so this all leads to much easier automation and integration, and in fact it's policy-based automation, wherein the sensors and the events and then the rules and the actions that we automatically go through that would otherwise be done by skilled network engineers are set ahead of time according to such factors as who the users are, their places in the network, or devices that are being investigated. And so finally, we see that this leads overall to improved network assurance, wherein the carrier-grade reliability that we have supports the unpredictable things that happen with network traffic. So bottlenecks can be eliminated, and in many cases, problems can be prevented before they even occur. And these innovations, as discussed earlier by Vince, come in our Aruba 8400 core switch, which actually comes complete with innovations such as full redundancy within the chassis. And we show two switches over to the left here, and one is the 8400, and that has a 19 terabits of switch fabric capacity. That's our modular chassis. And then there's also a fixed form factor that's available, and it features 2.5 terabits of switching capacity. Both of these platforms support several line card configurations that include 10, 40, and 100 gig. And then over to the right, you see, and Sue mentioned this earlier, the network analytics engine, and Vince also mentioned it during his presentation. And this product, this technology, is born of the modern operating system that you see highlighted in the middle. It's the Aruba OS CX. It's a database-driven operating system, and this is what provides the analytics data in the time series database and presents it to IT staff, or in some cases to the agents that will run on the box in easily readable and actionable formats. So all of this is fully programmable, and it's how the core of the Aruba switching network helps strapped IT departments and gives the end users, students and professors and other staff in the cases that we're talking about here, the experience that they need to get the most out of their workdays. And so just to give an example to show kind of the flow, how it works, let's look at, you see on the left the present mode of operation, and on the right future modes of operation for IT staff to work with the network's own telemetry that it provides in order to automate significant portions of their jobs. So the way things work today, typically networking or application problems, and sometimes you don't know which, is it a network or an application problem, could include maybe unified communications issues, such as phone or conferencing, videos being lost or tiling, and that's whether it's an educational video or Netflix, connection problems to the internet, or connected IoT devices such as projectors, which might be needed during the school day. So IT staff typically go right to the keyboard in response to the problem reports that often don't give much context as to what actually went wrong. And so as they look for things such as switching or routing topology changes, problems with IP address management, such as with DHCP or DNS, or maybe a layer 1 issue with a cable, it can be a bit of a fishing expedition, or to use the analogy shown here, a needle in a haystack problem. But the types of diagnostic tasks that I just mentioned are handled automatically with the analytics that are generated out of the core switch, out of the 8400 or the 8320. Agents are triggered automatically at the time of an issue, or can be even beforehand as the network starts to see things that may lead to an issue, such as higher than expected link utilization. So routines that are openly documented and available as part of the NAE, some of which involve machine learning technologies, will run the diagnostics and sift through that haystack so that by the time the IT person is involved, there's much more information to start with. And so in many cases, the steps to remediation are minimal, and in some, the fixes can actually be fully automated. And so it's important as our customers make these business decisions that they're able to verify and consider what the likely return on investment would be. What are the savings on the operational side? This is a case study that we've done with Friesland College in the Netherlands. And their challenge was to improve network performance and enable delivery of video-based learning technologies. So very bandwidth intensive, as Vince was describing in his case with Grove City, and of course everything has to be always available. So with the 8400 AOS CX and the network analytics engine, they enjoyed a full payback period in 13 months and realized a 3-year cumulative benefit of 166% ROI. And that is available on our website. So kind of in conclusion, how all this hangs together, you can see most of what we're known for, and indeed most of what we've been talking about on this call is things that we've done in the access layer of the network in order to give our users awesome experiences, simple experiences, secure, smart networks, always on, high performance, their roles and policies, as Sue was describing, stay with them the whole way. That's our absolute strength. And we also have all of this software around it, as we were talking about network management options and additional AI-based tools there, such as Net Insight, policy management, things like that, security with ClearPass, location analytics, all that stuff around the edge. Well, here what we've done also in fitting with the philosophy, the idea with how we put all this together, we've developed core networking technology, which is not usually associated with the core, or at least not traditionally, but which actually we have found, if designed right, does fit there quite nicely, because all traffic runs through there, and so we provide the visibility and the analytics in order to support all those experiences at the edge of the network. And so, yeah, basically this is all those three parts, you know, the core, the access, and all of our software is to build the campus for what we call an experience edge that takes into account the interactions of people, places, and things, uninterrupted experiences, optimized connectivity, and automated and simplified IT operations. And so we are now ready to say thank you and see what questions we have.
All right. Well, thank you so much, Alan, and thank you too, Sue, for excellent presentations, really. Well, we do have about 9 minutes left, and we do have a number of questions that have come in from the audience. So why don't we see how many of those we can tackle before the end of the hour? And Vince, I said we would probably be coming back to you, and indeed we are. There's a question coming in from Edward, who, when you described how the issue you had with the library, and then obviously you expanded that into a much wider rollout. Can you talk a little bit about how you deployed to the rest of the campus? Did you do it all at once? Did you do it over a break? Can you talk about the whole rollout and how you went about it?
Sure. So we kind of did it in little chunks. So the library we literally did over a 2-day period. So as Sue had mentioned in her section about you don't have to roll this out all at once, the library we basically did as a whole piece in a couple days. And then what we did after that was kind of the proof of concept to make sure that was going to work. Once that was successful, that would have been not far from our May graduation. After graduation, then we spent that summer doing all of our dorms, which is about 12 to 16 buildings. And we did 12 that summer. And the way we do wireless in a dorm might be a little different than some other areas do it in a residence hall. We actually use these Aruba 305 devices that are basically like what you would see at a Marriott or something, where it's a device that sits in the room and has a wireless access point in it plus 3 wired ports. So that whole thing does kind of dynamic segmentation. But if you're going to do an entire building, like we just knocked off buildings one by one by one by one. So it is pretty flexible on how you're going to do it. I mean, the fact that the students left on a Friday, we came in on a Monday and did Monday, Tuesday to do the library, button everything up and test Wednesday, and then the students came back following that and it worked fine, I mean, is a pretty big testament on how you can segment this. So it does not have to be an all or nothing. Now, one of the things you have to just be worried about is making sure you use the same SSIDs or different SSIDs, and students need to understand that if they're in some location, they have to use the old SSID. So in our case, we actually changed the SSIDs a little bit, just so students were aware of it. So our goal during that summer was academic buildings and as many residence halls that we could do. And then after that, we had 4 that we picked up over a Christmas break. So we were able to do that in buckets.
Okay. Now, just as a follow-up, you talked about how you did the residence halls maybe slightly different from how other schools do them. What led you to take that approach? That it was more of the sort of hotel approach. I think you used the word Marriott. What convinced you to go that way rather than maybe a way that many other schools are going?
Well, we're kind of held a little bit as a victim to how the construction of the residence halls are made. So since our campus is pretty old, the residence halls are made of a lot of cement, and so having a general access point out in the hallway and trying to map that was a little more difficult. So with more modern construction of residence halls, that's a little bit different. But in our case, we were concerned that we didn't want students, as they were moving further away from the access point, for example, if they happen to have a room on the corner, they're going to be the furthest from the access point, and they should have degraded performance. We didn't want that. So because of the way the buildings were constructed, it was much easier for us to say, you know what, we're going to put an access point in every dorm. So using these devices, these 305s, is like a personal access point. But it also allowed us to have mesh networking throughout the dorm. So we had coverages that were basically meshed together and provide phenomenal throughput for the students, because at the end of the day, that's normally where they're going to be viewing Netflix or doing homework. So there's so many different use patterns within a residence hall at any given time, right? It's kind of hard to figure out what it's going to be. So this gave us the most flexibility, and frankly is really easy to administer through the Aruba controllers. I mean, we have one configuration, we plug a new one in, it picks up the configuration, it's done. So it's actually a really great way to do that. But some schools that might have more modern residence halls may just do APs in different locations. We just really couldn't do that in the way we were structured.
Okay. All right. Well, thank you. Thank you for explaining that. We probably have time for one more question, and Sue, I'm going to come back to you for that one. Now, Vince at Grove City, I believe that they are primarily an Aruba shop. I think they've used Aruba equipment throughout, but a lot of schools have multi-vendor environments. And when you talk about this sort of next generation access features, are they available and can they work in a multi-vendor environment?
Sure, absolutely they can. Aruba is really focused on supporting multi-vendor environments, and the dynamic segmentation, which I covered, so you can insert it into a mixed environment. You can deploy a controller and a switch in ClearPass, and then that tunneling will occur for those devices and users that are connected to that part of the network. It's not going to mean that you can dynamically segment and tunnel all the traffic on your network by simply putting in the Aruba components, but the part of the network that you put the Aruba components in there will do that. And this is unlike some of the other schemes out on the market where you have to have an entire system built up of a single vendor.
Okay. All right. And to get that dynamic segmentation, do you have to replace legacy access or aggregation switches to achieve that?
Well, you just, it's sort of a no, but no, you don't, depending on the switch you have. For instance, if you've already purchased some Aruba switches, any of our 2920, 2930, 3810, or 5400R series, you can just do a software upgrade and you can get that capability. You have to have a certain software release. But you just need an Aruba controller, a switch, and ClearPass. Okay.
All right, great. Well, unfortunately, we have run out of time, and so I apologize to any of you who've asked questions that we were unable to get to at this point. So it is time for us to wrap up, and I really want to thank Vince DiStasi, Sue Gillespie, and Alan Sardella again for really excellent presentations and superb conversation. And I also like to thank Aruba for its support today. And one final reminder before we all go our separate ways, we will be sending out an email to everyone who attended when the recording of the webinar is ready. Thank you to all, and this concludes today's webinar. Goodbye.